A very good evening, guys. I hope you had a great day, right? And let us just wait for the other people to join. Then we'll start the session. Yeah. Good evening, guys. I welcome everyone over here, right? Let us just wait for one more minute for the other people to join in. Then I'll start the session. Okay. So I think people have started joining in, and we'll start the session now. Yep. So once again, I welcome everyone over here who has joined for this particular session. So in this particular session, what we are going to discuss is we are going to discuss about one of the very easy and interesting topic, time, speed and distance in terms of quantitative aptitude, right? So time, speed and distance, I can clearly say that it revolves around one basic formula, that is speed is equal to distance by time, right? So we all know that speed is nothing but which is equal to distance by time. So how and all we can use it? What are the minor changes which we have to do whenever we try to solve questions based on time, speed and distance, right? So that is what we are going to look into in in this entire session, right? So we are going to solve different types of questions which can be expected in terms of placement point of view, which is coming based on time, speed and distance, right? So the basic formula is speed is equal to distance by time, and the rearrangement of it is what we will be using it. So speed is distance by time, and I can say distance is equal to speed into time, and time is nothing but distance by speed, right? So this one minor formula is what we are going to use it for the entire question, but there is obviously some slight changes to the formula, but the logic behind it is going to be the same, right? So we are just going to modify it according to our requirement, and then we are going to solve a question. So what I'm going to do is most probably I'll be solving the questions based on which I'll be explaining the concepts as well, because this is comparatively an easy topic compared to all the other topics whatever we have discussed till now, right? So let us look into questions now. Let us look into time, speed and distance now, like questions based on that in today's session, right? I once again welcome everyone over here. So if you have any queries, or if you have any feedback, or if you have any suggestions regarding the session, please look into the description. So you have a form, kindly fill it. It will be really helpful for us to improve our experience with you, right? Great. Okay. So the first type of question what we can expect is based on average speed, right? So we know that generally speed is nothing but right. So we can say speed is clearly nothing but distance by time, right? So if you look at it over here, Anushri travels from her home to college at 40 km per hour and returns to her home at 30 km per hour. What is the average speed, right? So we know that average is nothing but sum of all the elements divided by the total number of elements. So in terms of average speed, we can go in such a way that so speed is equal to distance by time. Whenever I'm coming across a question based on average speed, I can go it in such a way that average speed is equal to total distance divided by total time taken. So that is the basic logic. So average speed is nothing but total distance. Total distance divided by total time, right? So whenever we go for questions like this, whenever we approach a average speed based question, the first thing what we have to remember is, again, it's same like the normal average whatever we calculate. So average speed is equal to total distance divided by total time taken. So that is a basic thing which we have to remember. Now, if you look at this particular question, right? So Anushree travels from her home to college at 40 km per hour and returns to her home at 30 km per hour. Right. So she's starting from her home. So I'm assuming the straight route, like she's taking the same route again while returning to the college also. So she's starting from a home, going to college and returning from the college, to the home. Right. So the distance is being kept constant over here. So the distance is constant means the average speed, directly we have a formula for that as well. So that is nothing but multiplication of two speeds, that is double the product of two speeds divided by sum of the speeds, right? Let me tell you how this came into existence. Now, whenever I need to calculate average speed, I clearly told you that it's nothing but total distance divided by total time taken, right? So here, I don't know what is d, but I can say the total distance is nothing but 2d, right? Because d, and again for the return journey the distance will be d. So d plus d, the total distance is 2d. And when she was traveling from home to college, it is nothing but 40 km per hour. So time taken for her onward journey, I can say d by 40. Yes. And time taken for her return journey will be d by 30. Because I already told you that average speed is nothing but total distance divided by total time. So if we simplify that, d will get cancelled over here. So 2, this will become 1 by 40 plus 1 by 30, which on simplification will again get into this particular step, right? So that is what, rather than going in this way, directly we can go in this particular formula whenever distance is kept constant. So whenever this distance is constant, average speed will be nothing but 2 into product of the speeds divided by addition of speeds. So we can directly use the formula and we can get the answer. So if I simplify that, I'll get 2 into 40 into 30 is nothing but 1200. So 2400 divided by 70. So if I simplify that, 240 by 7 will be the correct answer. Right. So I can go in this way and I can get the answer. Right. So whenever distance is constant, directly I can use this formula and I can go for it. What if time is constant and they are asking us to find the average speed, right? So whenever time is constant, average speed is nothing but addition of two speeds. That is the normal speed, normal average. So addition of two speeds, sum of the speeds divided by 2, right? So whenever t is constant, I can just find the normal average of the speeds. But whenever its distance is constant, this is the formula which we have to use for, right? So in general, if it is exceeding more than 2 terms or 3 terms, what I can do, total distance divided by total time will be nothing but my average speed. Are you people clear with this question? This is a very basic kind of question which we can expect. So whenever we try to solve a time, speed and distance based question, the first type of question what we can expect is average speed based question. Are you people clear with this? Okay, great. So the next type of question what we can expect is questions based on relative speed, right? I think like whenever you go for any movies, like maybe old movies, I hope that the current movies which we see, like I'm not seeing these kind of scenes, but whenever you go for any old movies or any movies which is having this pretty typical stereotype, in the olden days and all, like if you watch movies where the hero and heroine or the hero and villain chasing or heroine and villain chasing, these scenes will be termed to be pretty dramatic. They turn to be pretty like what is that, hilarious, that is what I can say. So let us imagine that there is a situation where the hero is running towards the heroine. So there is like after a very emotional reunion, they are meeting together, right? So obviously, what the people will do in the cinematography is like they will try to do it in such a way that the slow motion kind of thing will be there, right? Which means they are moving towards each other. So this is one kind of scenario which we can come up with. Or pretty much almost all the movies, the heroine will be chased by heroine will be abducted by the villain, or heroine will be going with the villain, or something like that will happen, and the hero will be like racing his bike, and he will be like trying to catch up, and there will be a major fight, right? So this kind of situation, what I can see, there is a person who is going and there is a person who is following, right? It's like chasing kind of situation, right? So one thing which is common in both the scenario, either it is a slow motion or either it is going to be in the other way, whether one person is chasing the other person. Can I say both the objects are in motion? Both the objects are in moving, like both the objects are moving, that is the hero and villain, and similarly hero and heroine. Both of them are moving. Can I say that? Can I say that, guys? Yeah, right? So these kind of situations actually come up, right? So similarly, there are questions like that also which will be given, right? So how it works? So the first case, let us imagine that they are moving in the same direction. That is nothing but the chasing direction, right? When one person is chasing the other. Let's say that A is the, hero, and B is the villain over here. So if villain is moving in this direction, hero also has to follow in the same direction only, right? So at some point they will meet, right? But if you look at any serials, or if you look at any movies, then you like I think it is going to take at least 1 hour for this scene to happen, because they will keep on showing that they are moving, and if it is in serial, that's all, like 1 week or 1 month they can play with this particular episode, right? So what exactly happens over here? Both the bodies are actually moving in the same direction, right? So whenever two objects are in motion, right, we cannot take the normal speed in which they are moving, but we will be considering the relative speed. So why relative speed means, since both the objects are in motion, with respect to this object we have to take care, because 1 second this object will be moving here, after 1 second this object will be moving here. So they have their individual speeds, but since they are in motion, at a particular time, what is their speed, or what is a relative speed between them, that is what we will consider. So how do we consider? Whenever two bodies are in motion and if they are moving in the same direction, we need to find the difference of their speed. That is nothing but relative speed. But when they are moving towards each other or in the opposite direction, right? Like that after a long fight, that emotional reunion between a hero and heroine, right? Unfortunately, in TV or in movies, it will be a very, very slow motion running. But in real life, definitely the hero will be having some speed, heroine will be having some speed, right? So they will be moving towards each other. That is, if this direction I'm taking it as plus, this is the opposite direction, that is minus, right? So they are moving towards each other, right? So in that particular case, what we have to do, we have to add their speeds. Are you clear with relative speed? So whenever two objects are in motion and if they are moving in the same direction, difference of speeds, and if they are moving in the opposite direction, addition of speeds. Are you clear with this, guys? Okay. So why this is important means, this is what plays as a major basic thing whenever we solve question based on trains. So time, speed and questions, you can expect n number of questions based on trains. So they will give a situation where they will ask you that how much time will be taken for one time to cross each other, or one time to overtake each other, or a person is walking on the platform. So how much time the train will taken to cross him? All these kind of scenarios where we will be using relative speed, because obviously the objects will be in motion and will be taking the relative speed, right? So that is the major role where this particular logic actually works. Let us look into a question, then I'll tell you like how it works. So two trains M and N traveling towards each other with a speed of 90 kilometer per hour and 70 kilometer per hour respectively, right? So they are traveling towards each other, so I can say relative speed will be addition, right? If the length of M is 600 meters and for N is 800 meters, then how much time will P and Q take to cross each other? See, let me take the train M. See, I'm very bad at drawing. I'm just like, let's say that there is a train. I'm just and that too, like drawing on a PPT, it takes so much of time. Let's take there is a train M which is moving here in this direction, and there is a train N which is moving in this direction, right? So there are two trains which are moving in the opposite direction to each other, and this train is of length 600 meter, and this train is of length 800 meter, right? Then how much time P and Q will take to cross each other? See, whenever we solve a train based problem, one important thing which we have to know about it, the basic formula for time taken is nothing but distance divided by speed, right? How we have to calculate distance here, how we have to calculate speed over here, that is something which we have to be very very clear about, right? So for example, if these trains has to cross each other, first of all they should be having this. When they will start crossing each other, if they are very very near to each other, that is like if this is the train M and this is the train N, if they are both at zero position, that is this train starting and this train starting, if both are at zero position, then I can say that they are trying to cross each other. So in that particular case, this entire N has to come this way and this entire M has to come this way, right? So this entire N has to come this way means it has to travel this entire distance of M and also its own distance to come here. Yes or no? It should be M and N, guys. Sorry, it's my mistake that I have given P and Q. It should be M and N. So what I'm trying to say is like whenever I'm going for train based question over here, this train and this train will start crossing each other, and whenever I'm trying to move it in such a way, M has to move from here, that is N has to be completely traveling across this M and it has to reach here, right? And similarly M has to completely cross this N and it has to go here. So what exactly happens? N will come here and M will come here, right? So which means they are traveling this entire distance of N and M together. Can I say that? So the total distance traveled by both the trains, including, it's nothing but length of their, sum of the length of the trains. Can I say that? Can I say that, guys? Yes, right. So whenever we go for train based problem, taking distance is something which is very very important, right? So why I have given platform or object means sometimes instead of a train they can also give length of a platform and all those kind of scenarios, right? So if there is a length of a platform, similarly the same situation, let's say there is a train like here, let's say there is a train M, which means the distance of M has to be traveled and also a distance of the platform has to be traveled when it is going to cross, right? So in that particular case, M plus the length of the platform will be considered over here, right? Otherwise, if both the trains are given, it is going to be length of train 1 plus length of train 2, right? So it's up to, whenever train question is there, definitely one train is going to be there. And the other thing can be a platform, or it can be a train, or it can be a person, it can be anything, right? So even if it is a person, if there is a train which has to cross a person who's standing here, right? So for humans, the width is negligible. So we can just ignore the width of this person and we can just take the length m. That case, this part will be 0. Right. So if there is a length, a significant amount of length that needed to be added, then we have to add it. Otherwise, we can ignore it. So the distance has to be calculated in this way whenever we go for a time, speed and distance based problem, that too especially based on trains. So this has to be m and n. I'm so sorry. And relative speed, right? Since both the trains are moving here, what I can see, we can add up the speeds. So 70 plus 90 will give me the relative speed, right? So in case if only train is moving and there is a platform which is given over here, only one object is moving, the other object is not moving, then it doesn't matter. I can directly take the speed of the train. So if both the objects are moving, then I have to take the relative speed. Otherwise, we can just take whatever the speed which is available, right? Okay, great. So in that particular case over here, what exactly will happen? And one more thing, whenever we solve a time, speed and distance question is, please make sure that you have everything in the same unit. If you look at it, traveling towards each other with a speed of 90 km per hour and 70 km per hour. So this is in terms of kilometer per hour, but the length of the train is in terms of meters. So either convert this as meter per second or convert that as kilometer per hour. So whichever is easy for you, do that so that you'll get the correct answer, right? Okay. So let us just do this question then. So this is m, this is n. So 90 kilometer per hour and 70 kilometer per hour, right? And I have meters. Now, kilometer per hour to meter per second conversion. So 1 kilometer per hour, how much meter per second we can go for it? So 1 kilometer per hour is nothing but I can write it as 1000. See. So it's nothing but 1000 meter. So 1 hour consists of 60 minutes and 1 minute consists of 60 seconds. So 60 into 60, right? So if I cancel it out, so 2 5s are, 2 3s are. So I can say 1 kilometer per second, kilometer per hour is equal to 5 by 18 meter per second, right? Similarly, 1 meter per second will be nothing but the ulta. That is 18 by 5 kilometer per hour. So this conversion is also something very, very important. We have to be very, very careful about the units. Otherwise, you will end up in a wrong answer. So please make sure that you are using it in a correct way. So in that particular case, what I'm trying to do, I'm going to convert this in terms of kilometer. Right, that is easy for me. Right. So time taken by train to cross each other, length. 800 meter is nothing but 0.8 and this is nothing but 0.6 kilometer, right? So 0.8 and 0.6, it's going to be 1.4 kilometer divided by 90 and 70 kilometer per hour. So 90 plus 70 kilometer per hour, sorry. So distance by time, so distance is nothing but 1.4, I'm doing it here. And relative speed is nothing but addition of speeds over here. That is nothing but 90 plus 70, right? So 1.4 divided by 90 plus 70 is 160. Can I say that? Can I say that, guys? Guys, can I say that? I'm just converting this. This is in terms of meter. I have just converted as kilometer. Or if you're finding it to be difficult, then convert everything else in terms of meter per second, right? So the length will be nothing but 800 plus 600, then you will get 1400 meter divided by 90 into 5 by 18. Or this will be totally 90 plus 70 into 5 by 18. You can do it in either way, right? So if I do that, I'll get 1400 into 18, right, divided by 160 into 5. So obviously 0 and 0 will get cancelled. 5 280, right? Yes or no? So if we cancel it out, we'll be getting our required answer. I think approximately it is going to be 2. Yes or no, guys? See, I'm just cancelling out everything. See, this is 1400 divided by 90 plus 70 into, this is in kilometer per hour, so it has to be 5 by 18, right? So if I do that, 1400 into 18, it will become, right? So this is 160 into 5. Yes, that's what I'm asking, whether it is, I mean, are you getting my point? Yeah. So if we simplify that, we'll get the correct answer, right? So it's very, very easy question, guys. Only thing is we have to be very, very careful about the units, and we should also understand this particular logic, right? Since they have not given options over here, I'm just leaving it like this. So this is going to be 1400 divided by 160 into 5, and 18 will go to the top, right? So if they have given the option, then it's very good, and we can simplify it and we can get it in terms of the required unit. And this, I have converted everything in terms of meter per second, so this is going to be in terms of seconds. So depends upon the unit you convert it. I mean, you convert it whatever the way it is required. Don't waste your time on simplifying, because majority of the questions, they leave the values in terms of fractions as well. That is the reason I'm saying. So simplify it to the most level, and if they are giving the accurate answer, then go for simplifying it. Otherwise, it's not necessary for you to simplify it also, right? Great. Okay. Let me give a minute time. Please try this question and give your answers in the chat. Let's see like who solves this question, who understands the logic over here. This is a very, very interesting question based on time, speed and distance. Let's see like who solves this question. Okay. I think I can solve the question now, right? I have given enough time for you people. Like, let me solve the question. Okay. Now, Sherlock fires a gun at 11:30 a.m. When Moriarty starts on his car towards Sherlock. Right. So Sherlock is here and Moriarty is the one who's moving towards Sherlock. And there is no information that Sherlock is moving, so I'm just assuming that he's not moving. Right. Sherlock fires it second time after 10 minutes and 30 seconds. That is exactly at 11:40 and 30 seconds. He's firing another gun. But at this time, Moriarty hears the second shot 10 minutes after hearing the first shot. Right. Since obviously he is moving over here, he is hearing the second shot after 10 minutes itself. Even though Sherlock has started firing it after 10 minutes 30 seconds, this guy hears it after 10 minutes. Right. So, can I say if he was staying at the same place, the distance would have remained constant, and so whatever the time taken, whatever the way, like initially he started firing here, he would have heard it, and after 10 minutes 30 seconds if he is firing it, he would have also heard it after 10 minutes 30 seconds if he was staying at this particular place. But since he was moving, right, so whatever the distance he has traveled, because of this movement he is hearing it in 10 minutes itself. Can I say that? Can I say that? Yes. So in that particular logic, what exactly I can do over here is the sound, right? The sound was traveling from here. I can say it would have traveled 10 and it could have reached at this particular point because Moriarty also started. So to reach this particular place from where Moriarty started, it would have taken only 30 seconds more, right? So can I say the distance traveled by sound in 30 seconds is equal to the distance traveled by Moriarty in 10 minutes? Can I say that? So, what is the thing which we have to equate it over here? Distance traveled by sound in 30 seconds is going to be equal to distance traveled by Moriarty in 10 minutes. Distance traveled by Moriarty in 10 minutes. Can I say that? Can I equate that? Yes. So, if I do that, then I'll be getting the required answer. Let me explain it again. See, Sherlock shoots the first bullet at 11:30 a.m. So he shoots the second bullet after 10 minutes 30 seconds. That is 11 hours 40 minutes and 30 seconds, right? Let me take it in this way. So this is Sherlock, this is Moriarty. Let's say that he is hearing the sound here, right? So if Moriarty were not traveling towards Sherlock, if Moriarty was not traveling towards Sherlock, he would have heard the second shot after 30 seconds, right? After 10 minutes 30 seconds would have heard it. So which means from here, if he was at this particular place itself, he would have heard it 10 minutes 30 seconds. But since he is at that point, the sound would have traveled for 10 minutes and he heard it already. right? So the sound has to travel remaining 30 seconds of time to reach the original place where Moriarty was there. So Moriarty has traveled 10 minutes, but the sound needs only 30 seconds to cover it, right? So he hears the second shot 30 seconds earlier, which means he covers the same distance that the sound travels 30 seconds. Can I say that? So if I can say that, that is the reason distance traveled by sound in 30 seconds is equal to distance traveled by Moriarty in 10 minutes. Right? So if we simplify this question, right? So we know that speed of sound is given in terms of 330 meter per second, which is given in the question. So the distance traveled by Moriarty, right? If you look at it, the question was what was Moriarty's speed in kilometer per hour, right? So I converted this as kilometer per hour, then we could get the correct answer, right? So the speed of sound is 330 meter per second. So the distance traveled by sound is nothing but 300 into 30, right? Why it is 300? Because I'm calculating everything in terms of kilometer per hour, right? So we need to do it in terms of equal time of 10 minutes, right? So sound 30 seconds. So 330. Sorry, it should be 330 into 30. Yes or no? So 330 into 30 seconds. So 330 into 30 will give me the correct answer. That is 9,900 meters because it is traveling for 30 seconds, right? So 1 minute it is 330 meter per second. In 1 second it is traveling 330 meters. So for 30 seconds it is going to travel 330 into 30, right? So the same distance is what traveled by Moriarty. That is nothing but 9,900 meters, right? So speed of Moriarty is what the question is. So 9,900 and we need it in terms of kilometer per hour. So but the time unit it is nothing but minutes. So if I have to go for converting it as in terms of seconds, I did that for seconds and then we know the conversion for kilometer per hour. So I'm doing it here. Or you can directly convert it for hour and you can go it in such a way also. So what I did was I calculated it for seconds first. That is 33 by 2 meter per second or 59.4 kilometer per hour. Are you people clear with this question? Guys, are you clear with this question? See, I'm just showing you like what level of difficulty questions can be asked in terms of time, speed and distance. That's the reason like I'm going with questions since many of you also wanted to solve questions, right? So that's the reason I'm going in this way. So the correct answer for this question is going to be 59.4 kilometer per hour, right? Great. So the next type of question which we can expect is in terms of race based question, preferably circular track based question, right? So whenever we go for solving a time speed and distance based question, the next type of question what we can expect is based on circular track. That is, people will be running in terms of circular and they will be able to get like when they will be meeting towards each other and all those kind of scenarios is what we will be able to get it here, right? So let people want me to explain the previous question again and I'll just do it in a very fast rate, right? So Sherlock was there, Moriarty was there. Moriarty is the person who's moving, right? So in that particular situation, what happens? Sherlock has fired a gun 10 minutes 30 seconds, right? So this guy is moving and he will be at some point after 10 minutes. So the time taken by Moriarty is 10 minutes. The sound also, right? After firing it, sound also would have taken 10 minutes and it would have reached here, But if the sound has to travel to the original place where Moriarty was there, it will take only 30 seconds more, right? Because he fired it after 30 seconds. So I can say that the sound that traveled for this 30 second is going to be the distance is going to be equal for Moriarty's 10 minutes distance, right? So that is the reason I can say distance traveled by sound in 30 second is going to be equal for distance traveled by Moriarty in 10 minutes. So if we equate it, we will be getting distance traveled by sound, that is 9,900 meter, which will also be equal to distance traveled by Moriarty. Then if I simplify it, I will be getting the correct answer, right? Unit conversion is also something which is very, very important. Okay, great. So I told you, right, the next type of question what we can expect is questions based on circular motion, right? So there are 2 or 3 people who will be running in a circular track, and they will ask you to calculate when will they meet for the first time any point on the circular track. Let's say that A is moving here and B is moving towards this direction, right? So both of them are moving, they are in a circular track, and A started moving towards this direction and B started moving towards this direction. So there is a chance that they can meet here or they can meet anywhere on the circular track. So how to calculate the time taken for it? Similarly, if they have to meet at the starting point itself, they have started together means, so this person has to complete this round and B has to complete this round and meet here. So when will they meet at the starting point itself? So these kind of questions are very, very common whenever you go for circular track based question, right? So whenever they are asking that if 2 or 3 people who are starting at the same point, but they are either moving in the opposite direction or they are moving in the same direction, it can be anything, right? So they can move in any direction, but if they have to meet somewhere at the same point, right? So what we have to do, we have to take the length of the track, that is nothing but circumference of this circle, or they will give the total circumference directly. So length of the track, whatever they give in the question, divided by relative speed. So again, relative speed, if they are moving in opposite direction, we need to add up the speeds. If they are moving in the same direction, we need to subtract the speed. So that is something which we have to be very, very clear about, right? So that is first point. And the second type of question what we can expect is when they will meet for the first time at the starting point, right? So starting point itself, when they will be meeting. So they started here and they want to meet again in the starting point. Then it is nothing but LCM of their time taken. That is how much time A takes to complete a round and how much time B takes to complete a round. The LCM of that will be the correct answer. So for example, if A takes 20 minutes to complete this entire circular round and B takes 30 minutes to complete the entire round, then the LCM of 20 and 30 is 60. So 60 minutes after only they will meet at the starting point again, right? So these kind of questions are very common. Are you people clear with this?